Hi girls, today we're going to continue our lesson in Lesson 7, Building Functions. Yesterday in 2.7.1 we were building functions based on the context. Today we're going to look at tables and graphs and determine what function fits the table and the graph. So let's take a look at our first example. Here's our first graph. It says, determine the equation that represents the equation between x and y in the graph shown. Well, right away when I look at my graph, I notice that it's an exponential. So since I'm building a function and it's an exponential, I already know I'm going to start with f of x equals a times b raised to the x. I also notice that it's a decreasing function. As x increases, y is decreasing. So in order to determine what I put in for A and what I put in for B, I actually have to go and find some points on the graph. So let's look at some points that are easy for us to find. Right here, I see this point right here, which has coordinates 0, -1. I can see this point right here easily, which has the coordinate points 1, -3, and this one I can easily read down here, and that has coordinate points 2, -9. I forgot to mention this is on page 197 in your workbook, so you should be following along with me. So get those papers out if you haven't done that yet. All right, so now I have my 3 points. The next thing for me to do is to figure out what my starting point is and how much I am increasing by. So if we look at my inputs are 0, 1, and 2. My outputs are -1, -3, -9. So let's take a look. Let's write this out as if it was a sequence and see if we notice a pattern. So I'm just going to place my output in a sequence. -1, -3, -9. Well, if I look here, I see that well, we know it's exponential, so we know we're multiplying by something each time. And I notice that we're multiplying by 3 each time. So I definitely know that my b value is going to be 3. I'm going to write that over here so I don't forget. So now I need to figure out what my a value, what my starting value is. And when we think about a starting point, because you can see this graph extends in both directions, the x-axis is an asymptote in this case, so it's just going to keep getting closer and closer to 0 without actually crossing it or touching it. If we think in terms of where we start, we think in terms of f of 0. So if I were to replace that as my initial amount into my equation up here, I would write f of x is equal to f of 0 times b to the x. Well, we know what f of 0 is right here. When we input 0, our output is -1. So that tells me that my a value is -1. So let's plug everything in and see what equation we have. F of x is equal to -1 times 3 raised to the x. So let's see if this works and if we get each one of our points. So let's find, based on our formula, let's find f of 1. We should get -3. Let's see if this works. F of 1 is equal to -1 times 3 to the first, which gives us -1 times 3, which is -3. So f of 1 is -3. which is what we got up here. Let's try f of 2. F of 2 gives us negative 1 times 3 to the second. Negative 1 times 9 gives us negative 9. So f of 2 is negative 9, and that fits our ordered pair up here. So we have found the function that fits this graph. Example 2. We look at the example. I notice right away it's a line, so I'm going to write f of x equals mx plus b. I know that's going to be the formula for this function. When I look at it, I need to identify some points now so that I can determine the y-intercept and also try and find the slope. So I notice my y-intercept is right here. My y-intercept is at negative 4, so the ordered pair is negative 4. So that means b is negative 4. Next, I need to find the slope. So I'll start at my y-intercept. I notice the very next point that's easy for me to read is right here. So if I look at the slope, it's a positive slope. So we know that slope equals rise over run. And in this case, I'm rising, and I'm going to go up 1, 2, 3. So 3 goes in my numerator, and I move to the right 1. So 3 over 1, my slope is 3. So now I just fill this in. F of x is equal to 3x minus 4. And there's my function. All right, last example. Example 3, we have a table. It says, a clothing store discounts items on a regular schedule. Each week, the price of an item is reduced. Excuse me. The prices for one item are in the table below. Week 0 is the starting price of the item. So it says determine a linear or exponential equation that represents the relationship between the week and the price of the item. So it's telling us again, the problem is telling us what our two variables are, the week and the price, and we also see it in our table, the week and the price. Again, we see week is the input or the independent variable, the price is the output or the dependent variable. So I can't tell just by looking at this whether or not this is linear or exponential. So let's take a look at the differences that we see. Over on my input side, plus 1, plus 1, plus 1. I do notice this is a decreasing function. I'm going from 100 down to 60, so that was minus 40. I went from 60 down to 36, minus 24. So right away I know it's not linear. The change is not constant. So I need to figure out what it is changing by. So if we're starting with an exponential, f of x is equal to a times b to the x. I need to figure out what my a value is, and I need to figure out what my b value is. So again, I'm going to take my outputs and I'm going to write them like a sequence because it's easier for me to see a pattern when I write it this way. And one of the things we learned when we talked about sequences, to look for the pattern, if we think it's a linear pattern, we know it's going to change by the same amount, called a common difference. And we know this isn't linear, we know it's exponential, so it's going to change by a certain amount called the common ratio. And we talked about how to find that common ratio. If I consider this my a sub 1, a sub 2, a sub 3, a sub 4, we said that you take a sub 2, that r is equal to, divided by a sub 1. In this case, 60 divided by 100, which is equal to 0.6. So it looks like I'm going to multiply by 0.6. Let's see if this works for the next one. Take out your calculator. we'll take 60 times 0.6. Let me grab my calculator. Here we go. Wow, that is going to shine bright. Well, this isn't going to work because of the lights above. We'll take 60 times 0.6, and we get 36. So yes, my B value is 0.6 because we're multiplying by 0.6 each time. So let's write this over here. B equals 0.6. And now I need to find when f, or find f of 0. So I look for my input of 0, and I look at what my output is. And that tells me my initial value. So my A is 100. So I'll come back to my function. F of x is equal to A times b to the x. And in this case, my starting amount, when f is 0, is 100. And we'll take that times 0.6 raised to the x. Let's try a few to make sure that it works. Let's take f of 2. When we input 2, we should get 36. Let's see if this works. 100 times 0.6 squared. Let's take out the calculator again, even though it doesn't show up very well. And this time we'll take 0.6. I'll raise it to the second power and multiply by 100, and I get 36. Let's try f of 3. Make sure we get that. So it'll be 100 times 0.6 to the third. 0.6 raised to the third equals times 100, 21.6. And that's exactly what we have in our table. So definitely this is our function. All right, so for the rest of the period, you are going to be working on workbook pages 201 and 202, problems 1 through 10. I'm not going to collect those. I'm not going to have the sub collect those. Hang on to those, and we'll go over those tomorrow if you have any questions. Homework tonight is section 2.7.2 in the text, pages U2 214 to U2 215, problems number 1 through 10. So I'll see you tomorrow, girls, and good luck with your work.